In example 3, part C, we have the function h of x equals sine squared x minus cosine x. And we can immediately make the argument that since sine x, cosine x are continuous on 0 to 2 pi, h of x is continuous on 0 to 3 pi over 2. So what we've just done is made an argument for why we can use the extreme value theorem. And that's always going to be our first step of applying the EVT, is checking to make sure a function's continuous on the closed interval. So now that we've done that, let's find the critical value. So we'll take the derivative. H prime of x is equal to, and I'm going to apply the power rule here. So sine squared becomes 2 sine of x. That's the power times base down 1. And so we don't do anything to the inside function, but now applying the chain rule, we do take the derivative of sine. And multiplying by that, we get cosine of x. And then I need to subtract the derivative of cosine. Well, the derivative of cosine is negative sine, and so this minus turns into a plus, and I have sine x. And we will set this equal to 0 to find our critical values. So the first thing I think I would like to do is factor out a sine of x, since we have that in both terms. So sine x times quantity 2 cosine x plus 1 equals 0. Then via the zero product law, we have two factors being multiplied equals 0, and that implies that either sine of x is equal to 0 or that 2 cosine x plus 1 is equal to 0. So sine is going to be 0 when x equals 0 or x equals pi, and 2 cosine x plus 1 equals 0 means that cosine x is equal to negative 1/2, and that's going to happen when x is equal to 2 pi over 3 or 4 pi over 3. So now we have everything we need to set up our candidates test. So x and f of x. 0, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2. And so plugging into the calculator, we get negative 1, 1.25, 1, 1.25, and 1. And so finally from our table, we can see that the minimum is going to be negative 1, and the maximum is going to be 1.25.